Hey kids, Flexing Teacher Weber here. We're going to wrap up looking at squares and square roots this week. I want us to do a review today that summarizes some of the main questions we've done. The first question I want to do is one we've done a lot of, where you estimate a square root using the perfect squares that surround that square root and a number line. So this question says, show how you would estimate the square root of 240 using a number line. So let's make a number line. Don't be afraid to make these assignments, these number lines nice and large. It's much easier to work on if you have a number line where you can easily put your numbers. Now remember, on top of the number line, we put our squares. On the bottom of the number line, we put our square roots. Okay, so to estimate the square root of 240, we have to know the perfect squares on either side of 240. Well, we have a perfect square chart we can use. So the perfect square right below 240 is 225. And I'm going to put that on top of the number line where I put my squares. On the other side of 240, the perfect square is 256. Now, what I want to do to accurately predict where 240 will go on this number line is I want to find the midpoint between 256 and 225. Now, the way I do that is this. I find the space between 256 and 225, and I can do that by subtracting. 6 minus 5 is 1, 5 minus 2 is 3. So the space between those numbers is 31. Now, I want to get the midway point, so I want to know what half of 31 is. Well, half of 31, I can divide that by 2, and I will get 15 and 5/10. So that means if I was to add 15 and 5/10 onto 225, I'll have the midway point of 225 and 256. So if I add 15 and 5/10 onto 225, I get the midpoint of 225 and 256 is 240 and 5/10. Okay, I want to estimate a square root of 240. Well, let's use our knowledge of perfect squares. The square root of 225 is 15. And remember, if we're talking about squares and what this means in real life, 225 represents the square, 15 represents its side length. The square root of 256 is 16, which means the square root of 240.5, or 240, has to fall between 15 and 16. So the square root of 240.5 is going to have to be 15 and a half. Now we want to know the square root of 240. 240 basically falls right there on the number line, right? It's basically 240.5. It's basically in that spot. So that's where 240 lies, and that's the number we want to estimate the square root of. So the square root of 240 is going to be basically 15 and 5/10. So if we're writing this, we would say square root 240 is approximately, I'll use those squiggly lines because that's not an exact answer, 15 and 5/10. And if you were to check that with your calculator, you're going to get something very, very close to that. So the first thing you need to be able to do in this section is to estimate a square root using perfect squares. Let's look at another question. Now, the thing we did yesterday was we used square roots, but we sort of went backwards. It says, I'm thinking of a number that has a square root between 7 and 8 and is a multiple of 12. Use a number line to find this answer. So, I'm going to start with a number line. I'm going to put squares on top. And I'm going to put square roots on the bottom. And it says, I'm thinking of a number that has a square root between 7 and 8. So I'm given the square roots in this question. So I'm going to put for my lower square root 7, my higher square root 8. So any number I put on this number line is going to have a square root between 7 and 8. So I've got to work backwards now. The square of 7 is 49 if I went 7 times 7. The square of 8 is 64 if I went 8 times 8. That means any number from 49 to 64 will have a square root between 7 and 8. But the answer I'm looking for is a number that is also a multiple of 12, which means if I skip count by 12s, I'll get that number. So if I skip count by 12s, 12, 24, 36, 48, 60. 60 falls on this number line right about here. So 60 is going to have a square root that falls between 7 and 8. And 60 is also a multiple of 12. So the answer to this question is 60. 60 has a square root between 7 and 8. And 60 is also a multiple of 12. So that's the second thing we had to do with perfect squares and square roots. We had to use them to find some sort of number or set of numbers using our knowledge of square roots. Now, let's do some problem solving with squares and square roots now. Now, the main thing to remember about squares and square roots, I've said this a lot, but you really have to try to picture this, and hopefully this problem is going to help you picture this. A square number is literally a square. The square root of a number is the side length of that square. Okay, let's look at question 3. A fitness center has a square hot tub with an area of 30 meters squared. They want to place a rubber slip guard around the outer edge of the tub. They have 25 meters of slip guard. Will it be enough to go around the edge of the tub? Okay. I think a way to understand this problem is to do some diagram drawing. A fitness center has a square hot tub with an area of 30 meters squared. Well, let's draw the hot tub. It's a square. And its area is 30 meters squared. Now, the first thing we should ask ourselves, is this a perfect square? No. The perfect squares start off with 1, then 4, then 9, then 16, then 25, then 36. So this is not a perfect square. Now, we want to know if 25 meters of material will be enough to go around this hot tub. So what we want to know is we want to know the side length of this hot tub. Because if we know how long the side is, we can measure our sides and determine if 25 meters of slip guard is enough. And when we're finding the side of a square, we are finding the square root. Now in this case, since we don't have a perfect square, we're going to have to estimate this square root. So we want to estimate the side length of this hot tub. I'm going to call that x. All right. So let's do what we would normally do. Let's make a number line. On top of the number line, we'll go squares. On the bottom, we'll go square roots. Okay, we need to think of the perfect squares below 30 and above 30. Well, the perfect square below 30 is 25. the perfect square above 30 is 36. The space between those numbers is 11. And so the midway point between 25 and 36 would be half of 11 is 5.5. So the midway point is going to be 30.5. Now, the square root of 25 is 5. The square root of 36 is 6. The halfway point between them is 5.5. If we're talking about the square root of 30, 30 is going to lie like right there. So the square root of 30 is going to be approximately 5.5, which means the side length of this hot tub is going to be approximately 5.5 meters. And since it's a square, or almost a square, it's not a perfect square, that means every side of this hot tub will be 5.5 meters. So we want to know if we have enough material to go around this entire hot tub. So I'm going to flip to the next page and we can figure that out. So we're going to calculate the perimeter of this hot tub. The perimeter is the distance around. There are 4 sides that are all approximately 5 5/10. So I can add those up, or I could do 5 5/10 multiplied by 4. So this is 10, 20. I'll write down the 0, carry the 2. This is 10, 20, and 12 is 22. There's a decimal there, so that's 22 meters. So that means the perimeter of this hot tub is 22 meters. The distance around is 22 meters, and we have 25 meters of slip guard, which means we have enough and we've answered the problem. So let's answer it. The perimeter is about 22 meters. We have enough slip guard. Oops, spelling mistake there. We have enough slip guard. All right, so that's how we can use square roots to answer problems. Now, I'm going to make another video that gets you started on the review assignment I'm going to give you, but the review assignment, you're basically going to have to do questions like this. All right, so in my next video, I'm going to have the review assignment on there, and I'm going to just get you started on that review assignment so you'll know what to do. Hopefully this review helps. Flexing Teacher Weber, out.